Okay, so let's see if I can show you guys how to do a design optimization study. I've tried it like, honestly, like 8 times now, and every time Solidworks has crashed. But we carry on. So, top tip, by the way, for whoever might be doing a design optimization on this manipulator plate, don't pick this right one because it's a mirrored component. And I was trying this in like a previous attempt at this video, and you can't do design optimizations on mirrored components, so you'll have to just pick this left half because this one has all the dimensions. So anyway, just that was a little side note. However, let's just pick this bottom plate because why not? So yeah, open up the part that you're going to want to do your study on, and you're going to need a static study. So go and make sure your SolidWorks simulation's enabled. Create a static study. It doesn't have to be a new static study. You can use like an existing one that you have set up already if you want, but just for the purpose of this little tutorial thing, I will just set up like a little bit of a fun one. Just cause. So let's just pick our geometries. There we go. Boom. Make sure it runs because otherwise you're gonna have problems. Sweet. Looks pretty good. So now that we have our static study working and we can see the stress in our plate, maybe we want to say, hey, how thin can we go with this plate before the maximum stress exceeds the yield strength, and then the plate fails. So the way that you're going to be able to check that with SolidWorks is do a design optimization study. So you're going to want to come down here to your tabs on the bottom, right click on your static study that you're running, and go create new design study. And then yeah, you're going to get this new interface, and this is where you're going to do your optimization. So down here, you've got your variables, your constraints, and your goals. So your variable is going to be, things that are varying between each iteration. So, we're essentially going to run a whole bunch of iterations on this static study that we already have set up. So in this case, we're going to, want to vary the thickness between each iteration so that we can find the optimal thickness, the minimum thickness even that we can have before this plate fails. So that's what you're going to pick as your variable. Your constraint is going to be like a design constraint on the part that we impose. So say that we need the factor of safety of this guy to be at least 2, just for example. You can set that as a constraint, and then when SolidWorks is doing its iterations, it'll know that if we calculate that the minimum factor of safety on this part is less than 2, well then it doesn't meet the design constraint, so it's a failed iteration essentially. And then you've got your goals. So why are we doing this? Well, it's because we want to make this plate like as thin as possible, or maybe like as light as possible. So you can set a minimal mass as your goal, and then SolidWorks will try to achieve that goal. So let's go ahead and just run this a little bit, just show you guys how to set it up. So under your variables, you're going to go click on this drop down, go add parameter. When you click that, you should get a pop-up of like every dimension on the component, and you're gonna sometimes you have to look for it, sometimes it's like hidden out back, but here we found the thickness, and that's what we want to iterate on. So you're just going to click on it, and then up in this window here, you can see this value populated with the dimension 3.175 millimeters, and you can also see down here in model dimension that it's boss extrude bottom connector, blah blah blah. So we know that worked. You got to give it a name. SolidWorks will not let you move on without giving it a name. So yeah, here we got our thickness, and then there are a few ways that you can iterate on your thickness. Generally, range with step is the easiest. You can you can have a comma separated list of discrete thicknesses you want to try in discrete values if you want, or a continuous quote unquote range of thicknesses, but that's often quite taxing on your computer. So generally, range with steps is the way to go. So you'll be able to pick, the minimum thickness that you're willing to try. So maybe we're willing to go down to, a 1/4 of a millimeter, and the maximum we're willing to go, well, what were we at, 3? So maybe we're not actually willing to go thicker than 5 millimeters. So you can enter those in as your minimum and your maximum, and then you're going to have your step here. So this is going to be, how many millimeters it will add to this minimum in each iteration. So maybe 0.25 is a bad example. Let's just go 0.5, because then I can say, all right, 0.5 millimeters here, and then up here you can see the total number of iterations that it's going to run is 10. So it's going to run 0.5 millimeters plus, and then it's going to run 0.5 plus 0.5, 1 millimeter, then it's going to run 1.5 millimeters, blah, blah, blah. And so it'll run 10. So keep an eye on that, because if that gets too big, you're going to be sitting here all day. So next we're going to want to add our constraint. So you can come down here to your constraints, add a sensor. There's a whole bunch of these. Generally for constraints, what you're going to want to do is go into simulation data in the sensor type, and then you're going to want to come down to data quantity, and you can pick your stress, or you can pick whatever you want, but factor of safety is a good one. It's an easy one to set up. So you can click factor of safety, say, okay, I want to find the minimum factor of safety across the whole model, between all of my iterations, and then this box will be checked to say that we're just going to use the yield strength that is applied to the material that you have applied to the part. So yeah, you can add that, and yeah, so now you've got factor of safety is less than 1. Well, that's not good, is it? So you can have it be, you want it to be greater than 1, or I think we said 2 earlier. So you can, now you're telling Solidworks, no matter what, the factor of safety must be greater than 2. So yeah, so that's your constraint that you might set up. If you were still curious to look at like the stress or something, but you didn't necessarily want to have it as a constraint, what you can do is come in here into constraints, add another sensor, go to simulation data, here's your stress, right? So maybe we want that in Newton meters, something like that. Anyway, it'll, here's the maximum stress in the part. What you can do if you just want to know the stress in each iteration but not have it as a constraint is you can add it here and then click monitor only, and that just means that it's going to record the stress for you in each iteration, but it's not actually doing anything with it. It's just like for your information so that you actually know what the stress is each time. Finally, we'll add our goal here. So the one it defaults to is the easiest one to use, just mass. So let's just add our mass here and say, hey, we want to minimize the mass. If we wanted, we could maximize the mass or have it as close to 600.56 kilograms as possible, but no, we want to minimize it. So now we've got our thing set up. We're iterating our thickness. These are our constraints. Here's our goal. We can run it. Let's see if it'll run quickly. You can kind of watch it run in the background, which is fun. Okay, well, I probably shouldn't have picked one with 10 scenarios for this like little mini tutorial thing, but oh well. Here we are. So we got a successful result here. So you can see that it ran 10 iterations of our static study with these thicknesses from 0.5 to 5 millimeters. These red ones mean that they didn't meet our criteria. So we said the factor of safety has to be greater than 2. Well, the factor of safety is only 0.4 here and 1.5 here. So actually this scenario 1 like totally failed, and then these ones all worked. However, it'll pick your optimal one for you. So this 1.5 millimeter plate is the optimal one because it is, you know, the one with the lowest mass that satisfies our minimum factor of safety requirement. So yeah, so there you go. Now you've got your, you can double click on them, by the way, to switch between them, you know, for your screenshots or whatever for the report. And then when you come to static study, you know, when you mouse back over to this tab, it should keep the dimensions of the most recent one that you clicked. Yes, see, now it's a bit thinner. And then you can get your diagrams and everything for this specific iteration. Yeah, so here's your optimal thickness. It's apparently 1.5 millimeters. So yeah, that's how you set that up. Hopefully that was helpful. If not, well, oh well. Let me know, and I can try to help you guys out some more or whatever. So yeah, take it easy, guys.